Okay, so I'm going to work this one with you, and then I'm going to leave you to do number 17. But I will show you the answers to number 17, A and B, to make sure you know or that you're getting it right. Okay, so you don't have to have a piece of graph paper. I just need an X and Y axis and the general vicinity of the point 12.5. So I know I'm going to be going my x-axis, and here's my y-axis. I'm going to be going to the right 12, and I'm going to be going down 5. So that's the point, right 12 and down 5. And then for the other endpoint, I'm going to be going left 3 and up 7. And notice that I'm just, kind of sketching left 3 and up 7. And I got to figure out how far apart those are. So the distance formula says find out. And even if I use the distance formula, I always draw my right triangle. Okay, this is what I'm actually finding the length of. That's the segment that I'm finding the length of. But I'm still going to use these two legs to help me do that, because the distance formula says find how far apart the x values are. So this x value that's -3 and this x value that's 12, that's how far apart these two are. Because remember, we know what the coordinates of that point is right there. That would be left -3, but it would be down -5. So how far apart, how long is the horizontal line? It's how far apart the x values are. So the right side right here, 12 minus a -3. 12 minus a -3, you know what to do when you minus a negative. That's 15 units long. Now for this one, we subtract the y values, okay? So I'm 7 up this way, I'm 5 down that way, so that's going to be a total of 12. We do 7 minus a -5. That ends up being 12. So we've got a triangle now, and if we're doing the distance formula is the same thing as Pythagorean theorem. We've just already solved for the length of that side right there. We found this side right here, which is 15. So we have to square it. And then we found this side length right here, which is 12. And we have to square it. And then we're going to add those squares together. I think that's 225. And that's 144. And when you add those two together, you get, what is that? 369. So we want to see if 369 is a perfect square or not. So if you take the square root of both sides, I'm having to get my calculator out here. I don't recognize that, but I am thinking that this is a Pythagorean triple, to be quite honest with you, because I have a side that's 12 and I have a side that's 15, and then I have this side over here that's missing. So I recognize that this is 3 times 4. I recognize that this is 3 times 5. But that would be a 4, 5, something else triangle, not a 3, 4, 5. That was what I was hoping for. So it may not be. So I'm going to take the square root of 369. And I got to take the square root of it. Yeah, I get 19.2. About 19.2. All right, so it didn't tell me to round. So if it, in the case where it doesn't tell you to round, you have to simplify the radical. If you don't know how to simplify the radical, shoot me an email and I will hook you up with a video that will teach you how to simplify the radical, because we could round, which is the most logical thing to do in geometry. But we could also take this number right here and simplify it into its simplest form. And that would look like this. That would be 3 square roots of 41. Now, if you're wondering how in the heck I got from here to here, this is showing you over here how we did it, because they're showing you, okay, you have to know that 369 can be factored into 9 times 41. Well, why would you want to factor it into 9 times 41? You want to find factors of this number right here that are perfect squares. So you try numbers like 4, because it's a perfect square, 9, it's a perfect square, 16 is a perfect square. You try numbers that you know that are perfect squares. Because if it will factor, you can separate those two factors and take the square root of 9 by itself, take the square root of 41 by itself. Why would you do that? Because you know what the square root of 9 is. And so that gets it into what it's called its simplest radical form. So this could be the answer on a multiple choice on the multiple choice test. But then again, they might round it to the nearest, whatever. Some calculators will do this, and it's not even the big fancy graphing calculators. It's the lesser expensive, the $25 TI calculators and Casio calculators. They will simplify a radical for you. The upper level math, like the TI Inspires or whatever, unless they've just added it, I don't think that they'll simplify radical. So, anyway, that's the correct answer. Now, you should stop the video, pause it, so you can now go and try to do number 17. So go ahead and stop it right now. Try to do 17A, 17B, and then turn it back on, and I'll show the answers. Okay, so here are the answers to number 17A is 17 units. It came out to be a nice number, must be a Pythagorean triple. And then 17B did not come out to be a Pythagorean triple, so we had to get either a reduced value or a rounded value. Okay, so be sure you are able to do that, because I can tell you that questions on the Pythagorean theorem are on your final, absolutely on your final.